A lot of times people will ask me, what is my favorite math subject? And my favorite math subject is, I think, abstract algebra. I think it's because it's the one that I studied the most. I spent more time learning abstract algebra than other more advanced topics. So like if you look at all of like the upper level or higher level math subjects, like number theory, abstract algebra, analysis, topology, the one that I feel like I spent more time on was abstract algebra. And this is a book here that I've used as a reference. I've done some of the exercises from this book, and I've read some of the sections. I didn't use this for a course. I used this primarily for self-study. And it's an interesting book because it has a lot of things that other abstract algebra books don't have. Like right here you see already, there's a bunch of stuff on symmetry. And so we're going to look at some of the contents of this book in a minute. But if you want to learn abstract algebra, like if you really want to learn it, the biggest thing you have to know, which is something you have to know for most high-level math, is some basic proof writing. So you can get that by learning discrete math or by taking a course on proof writing, or just learning about proof writing by watching YouTube videos and getting a book on proof writing. Once you know some proof writing though, I feel that abstract algebra is a very friendly choice. In fact, I feel like it's almost easier to jump into abstract algebra than linear algebra. My experience with linear algebra, I think, was harder than my experience with abstract algebra. I feel like I enjoyed abstract algebra more. And so I think it's a good subject for someone who is new to proof writing and wants to learn about algebraic structures. So in abstract algebra, you look at these sets, and these sets have properties, and they have names. We have groups, rings, fields, modules, vector spaces. All of these are called algebraic structures. It's a set with some properties, and they satisfy some axioms. And you study them in courses called abstract algebra. So this book is really unique because of some of the topics it contains. It's called Modern Algebra: An Introduction. It's by John R. Durbin, and this is the second edition. I don't know if this book is still in print. I don't know if there's newer editions. I don't know if it's available, but if it's available, I will find it and I will leave a link in the description so you can check it out if you want to. It's a nice, well-built book. It's hardcover. I've had it for a long time. This one is copyright 1985. Abstract algebra is a really fun course. You have some really fun proofs, I think. And it's just cool. You get to study these things called groups, and rings are really fun. And and it starts easy. When you first learn about groups, it's easy. And then you learn all this group theory. It gets more and more complicated. You get to these things called Silo theorems and finite abelian groups, and things get a little more complicated. And then you jump to rings, and it's like you start over, and it's easy again. And so I think that kind of makes it fun for people. And then you get to fields, and again, it's easy again. So every time you get a new algebraic structure, you start with the basics, and it's easy. And so I think that's exciting for people because people like what they understand. And I think that abstract algebra is good that way because anytime you have a new algebraic structure that you're studying, you learn about the basics. And so it keeps reinforcing the basics. You see how they're related, and you see how a lot of the proofs are related, and it makes your math a lot stronger. So this one starts with mappings and operations, which is good, in particular because you want to know what binary operations are. So it talks here about composition as an operation, invertible maps. And then it talks about groups, and very quickly they go into permutations, and that's probably because they talked about mappings in chapter 1. This is huge. Equivalence relations are all over mathematics, and so the fact it talks about that early is key, as do most books on abstract algebra. And then more on groups. This is classic stuff here. I actually have videos of probably every single proof in this book, or many of the proofs in this book from this chapter. I have a full playlist where I go over everything you need, starting with equivalence relations, and it goes through everything all the way to the proof of Lagrange's theorem and perhaps a consequence or two of Lagrange's theorem. So I have all of that proved actually in playlists here on the channel actually, so that's kind of cool. I just realized that. Rings, I have a couple introductory ring videos as well. Integral domains and subrings. Sometimes different books have slightly different definitions, and that's one of those nuances with abstract algebra. And the more you learn mathematics, the more you realize that those nuances come about. I have an old book written by Emil Artin. It's called Galois theory, and the way he defines field in that book is very different from the way that field is defined in modern books. So little things like that are annoying, and it's just part of mathematics. Number systems, group homomorphisms. Here we go, the fundamental homomorphism theorem, that's a big one. Applications of permutation groups, symmetry, So that's a nice chapter here. So this here on crystallographic groups is not something you often see, so kind of unique for an abstract algebra book. Polynomials. So if you want to learn field theory, you need to learn about polynomials first. I know this because I taught myself field theory. It's one of the subjects that I never learned in school and I needed for further studies in abstract algebra. Quotient rings, something you study as an undergrad. Field extensions, polynomial equations, geometric constructions, again, something that a lot of times you won't study in a classroom setting. Algebraic coding, lattices, and Boolean algebra. So it doesn't have everything. There's a lot of stuff that's not here. It does have Celo's theorems, but there's a lot of stuff here missing. It's an introductory book, but it's a very good book, and it gives you alternate proofs. So when you're learning something and you're reading a certain abstract algebra book, you can look to this one and get more information. So for example, let's just see, I'm pretty sure, let's go to the index here, and let's look up group actions. See if we can find that here. Group actions, group acting on a set, page 171. So let's go there. So if we go to groups acting on a set, so group actions are something that you might not study in an undergrad course. And so this has some information on that. Here it talks about groups acting on sets. It starts with the symmetries of the square, which is really cool. So it spends a lot of time on symmetries. And here you get some more examples here. So stuff like this, you can find in this book that a lot of times you won't find in other books. So it does have some specialized topics. Is this the best book for learning abstract algebra? I'm going to say I don't know. I like the book by Saracino because that's the one I used. I use this one mainly as a reference, but I certainly think it's a good book and one worth having. And I bought it, and I'm very happy with it. It does have some answers, which is typical of most abstract algebra books, and that's better than no answers. So yeah, I think it's worth getting. It's a good one. I use this book, again, mainly as a reference. I remember referencing certain things and reading certain proofs and thinking, oh, that's a cool way to do that. I remember going from Dummett and Foote back to this one, back and forth a couple times for a couple weeks there when I was learning some mathematics. But yeah, pretty good book. And it's the one by Durbin. It's got decent exercises, some answers. It's an introductory book with a different take. It's got different topics and just different mathematics than you would see in other abstract algebra books. So yeah, I'll leave a link in the description in case you want to check it out and start learning some abstract algebra. It's certainly one you can start with. Let's just look at the very beginning so you see how it starts. Let's skip the introduction and go to the first chapter, which is on mappings and operations. And you see it starts with a definition. A mapping from a set S to a set T is a relationship, rule correspondence, that assigns to each element of S a uniquely determined element of T. The set S is called the domain of the mapping, and the set T is called the codomain. And then it goes through here and it gives you an example. So we have S equal the set containing the symbols X, Y, Z, T, the set containing the numbers 1, 2, 3. Define alpha, and then they define alpha. So of X is 2, alpha of Y is 1, alpha of Z is 3. So X goes to 1, Y goes to 2, Z goes to 3. You have a mapping, and then here they have a picture, right? X goes to 2, Y goes to 1, and Z goes to 3. And they give you different mappings here, and they talk about other things, I'm sure, next. It's probably talking about one-to-one mappings and onto mappings, and these pictures are really good for explaining that. I have a couple of videos, older videos, where I use pictures like this to explain one-to-one and onto mappings. And then you get some exercises here. You see they're related to onto and one-to-one. Very typical of most books. I actually haven't read the beginnings of this book. I've only used it as a reference for some more advanced topics. But yeah, pretty good stuff. Here's a proof of Lagrange's theorem. I actually have a video for this on my channel as well. It's kind of cool. It's fun looking at this and saying, oh yeah, I have a video for this. It's just kind of fun opening up the book and seeing these things. Lagrange's theorem is super important. Here it is. If H is a subgroup of a finite group G, then the order of H is a divisor of the order of G. Yeah, good stuff. Brings back a lot of memories. Applications of permutation groups. This is cool too. So a lot of this stuff, well, Celo's theorem and then finite symmetry groups, a lot of this stuff you won't see in other books. So again, I think of this as kind of like a little specialized book. All the symmetry stuff, I know Arton's book has a lot of stuff on symmetries, but a lot of other abstract algebra books don't have this stuff, so that's pretty cool. I studied symmetries when I took a graduate level course in abstract algebra, so I did not see this type of stuff as an undergrad. So yeah, a lot of cool mathematics here that you won't find in other books. Anyways, probably should end this video. Just wanted to show you a random book I have here from my collection that I've used as a reference. It's a pretty good book for beginners. Is it the best one? I don't know. Is it the worst one? Certainly not. I think it's a good book. It's called Modern Algebra and Introduction by John R. Durbin. And I'll look for it. I don't know if there's any copies available, but I think it's worth getting if you can get it inexpensively. I'll try to leave a link in the description. Also, if you want to learn mathematics, I actually do have a course on abstract algebra with assignments. It doesn't have as much information as this book does, but I would say it has maybe, I don't know, 70% of what you would learn in a college level course, so quite a bit. If you decide to buy my course, please use the links from my website, mathsorcerer.com. The courses are actually on the Udemy platform, but if you use the links from my website, it helps me greatly, and I lowered the price to make the prices as low as possible, so if you use my links, you will get a low price. So yeah. And if you feel like you found any value in this content at all, subscribe if you want to. It's up to you. And what else? Oh yeah, I do have another YouTube channel on fitness, the Fitness Sorcerer. I like to train my mind and train my body every single day. And so I thought, you know what? I already have the Math Sorcerer. Let's do the Fitness Sorcerer. So check me out there if you're into fitness, if you want to. Until next time, the most important thing you take away from this video is that this is a decent book on abstract algebra, or modern algebra, as John Durbin calls it. And it's got some interesting topics, especially the symmetry group stuff, not something you see in every abstract algebra book. Until next time, good luck, keep doing mathematics.